Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our special CoCoRaHS Weather Talk webinar on significant weather events of 2022. A very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from sunny Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we're recording this talk today, and it will be available later this week on our website. All of our Weather Talk webinars are sponsored by the generous donations from listeners just like you. Well, we're excited to have back with us once again our good friend Greg Carbin. Greg is the Chief of Forecast Operations at NOAA's Weather Prediction Center in College Park, Maryland. Each year, Greg puts together a presentation on the top 10 weather events in the United States during the previous year. Greg has given these talks to packed rooms at various weather meetings around the country. And since today is Groundhog Day, this might wind up playing every day for the next week. We never know. Greg, it's great to have you back with us today, and we really appreciate you joining us.
Hey, thanks, Henry. And yeah, let's hope we don't repeat some of these events we're going to go over today, although the atmosphere does have a tendency to do that sometimes.
Okay, take it away. Yeah.
Okay, let's see here. Let me share my screen. Excuse me. Get this underway.
And Greg, you got muted somehow.
Test.
We got you now.
Okay, very good. And you can see the Meteorological Memories 2022 screen.
Yes, it's looking good.
Excellent. So let's get underway here. So a quick refresher, these are my meteorological memories, some interesting weather events across primarily the contiguous United States for last year. Presented in mostly chronological order. These are not an official ranking or anything like that with respect to NOAA. They're just some interesting events that I gathered data about and dug into that data a little bit to learn some more. And some of them you might know, some of them you might not. This year, I was really pressed for time as far as the active weather we had throughout the year. So basically, I kept trying to come up with the list and of my 10 memories and kept struggling to put together content. So this is kind of a reduced version from prior years, but I'll go into as much detail as possible using essentially one slide for each of the 10 events, and then we should have plenty of time for any questions at the end. So let's get underway here. And thanks to CoCoRaHS for inviting me today. Number one is the sneak attack snow event that occurred across parts of Kansas, western Kansas, northeast Colorado at the end of January last year, just about a year ago. Several locations saw accumulations that approached or had even exceeded 2 feet. Mount Sunflower, Kansas reported 27 inches of snow, which came in within 3 inches of the Kansas state record. And just miles away, substantially less snow fell, a testament to the narrow width and the limited movement of this long duration snow band you can see set up there on the radar. And the total accumulation is the image on the right there, a little square showing that this was the greatest 24-hour accumulation of snowfall for that particular day anywhere in the nation. And again, within 3 inches of the state record. And let's go to the next slide. So Boston got 23.5 inches of snow on Saturday, January 29th, just a few days later from the Kansas event. And it's interesting to note, at first I thought, well, maybe it was that disturbance that moved through Kansas that generated the deep cyclone off the southeast and eastern U.S. seaboard, but it was not. This was a different disturbance just about 4 days after the Kansas event. And this was the 7th biggest snowstorm of all time in Boston's recorded history. Certainly quite a contrast from this winter where they've had very little so far in the winter of 22-23. The record still stands at 27.6 inches and was set back in February of 2003. This was a nor'easter bomb, a rapidly intensifying low pressure system that developed over the Atlantic Ocean on January 28th through 30th. About 1 to 2 feet of snow and blizzard conditions along the coastline from Delaware to Maine. The event was classified as a Category 1 snowstorm in the Regional Snowstorm Index. So Boston tied its greatest one-day snowfall, almost 24 inches, 23.6 inches at the airport, and this low pressure system intensified at nearly double the rate of the classic bomb cyclone, dropping 35 millibars in an 18-hour period, and at least 100,000 people were without power during this storm. That was memory 2. On to memory 3. A significant early spring tornado outbreak occurred during the evening hours of March 5th, 2022, across the Midwest, primarily in the state of Iowa. And this tornado outbreak then transitioned into a damaging wind event across parts of northern Illinois and Indiana. Multiple tornadoes were reported, several of which were produced by a dominant supercell in central Iowa. One long track, low-end EF4 tornado caused major damage near the towns of Winterset and Norwalk, unfortunately resulting in 6 fatalities. Multiple other supercells spawned along an area of moderate destabilization in northern Missouri, prompting further tornado warnings in southern Iowa. And as the storms entered a very favorable environment for maturing, large hail and damaging wind gusts were also accompanying some of these storms. And this was the first EF4 tornado to affect Iowa since October 4th, 2013. It was the deadliest tornado in Iowa since May 25th, 2008, and the longest track tornado in Iowa since April 27th, 2014. So a number of pretty significant events broken by this particular event, and a little early, I would think, across Iowa in March. You usually think Iowa would be more susceptible to severe storms, perhaps come April, May, or June. So this is well ahead of the normal onset of severe weather activity for this part of the country. And you can see a picture of the large wedge tornado there in the upper right, and that's pretty much the track of the cell across the south central part of Iowa. On to event number 4. This is the historic long duration blizzard that affected parts of the northern Rockies and northern plains from April 12th through the 14th of 2022. And what I'll do here is I'll set this up. Hopefully this will show through the video. As I'm reading the rest of the narrative here, we'll start this video up. Actually, it has some music with it. Daily max snowfall records were set at several locations, including 13.9 inches at Billings, Montana, 10 inches at Bismarck, North Dakota, 11 inches in Grand Forks on April 12th. And drifts of over 8 feet were measured in portions of North Dakota, and Minot reported the state's highest accumulation with 36 inches. However, this 36-inch report from Minot was not able to be used to break the 34-inch 3-day accumulation record, as it was not taken at the official climate site in Minot. In the wake of this storm system, numerous record cold temperatures were observed from central Montana into the northern plains and upper Mississippi Valley between April 12th and 16th. And there you go. You can see the drifts piling up there on that video. You see the evolution of the cyclone there across the Great Plains and up into south central Canada. And then in the lower right, the total snowfall accumulation primarily across North Dakota. All right. Whoops, we skipped one here. Let's go to number 5. So what a difference the monsoon can make. We're now moving into this late spring, early summer months here, but heat, drought, and wildfires were really ramping up across parts of the Southwest from April through May. The Hermit Peak fire was the largest wildfire on record in New Mexico and was only 50% contained by the end of May. And this was after both April and May 2022 came in with some of the hottest and driest conditions on record across the Southwest. Things began to turn around, especially for New Mexico and parts of Arizona, when June precipitation in these areas ranged from 200 to 800% of normal, a remarkable turnaround. While drought was eased in some areas, flash flooding became more of an issue than fires. By mid-August, as shown in the New Mexico drought maps, the area of extreme to exceptional drought across the state was reduced by over 60%, and really quite unusual to see this kind of turnaround, especially during the hottest time of the year. And it was really all due to the anomalous moisture. As you can see there on the far left, this is a reanalysis anomaly plot showing the precipitable water anomaly from base climatology, and values upwards of an inch, inch and a half above normal across the Gulf of California into the lower Colorado River Valley, basically contributed to a daily afternoon and evening thunderstorm development, which brought abundant rainfall, especially to parts of western New Mexico, and really turned the drought conditions around in that state. On to number 6. July was quite a month of extremes across the contiguous United States. One unusual aspect of this came to my attention toward the end of the month when I looked at the National Weather Service map of watches, warnings, and advisories and saw this alternating heat and flood pattern hopscotching across the nation. It was the second warmest of any month on record in Texas, with an average temperature of 87 degrees. The all-time warmest month on record for Texas occurred in August 2011, with an average temperature of just a degree higher, 88. While the heat contributed to a continuation of drought in some areas, it was extreme instability and moisture on the edges of this heat dome that contributed to excessive rainfall and flooding in other areas. The two most pronounced and deadly flooding events of the month occurred across the St. Louis area on the morning of the July 26th. And then 2 days later, just downstream on July 28th, the deadliest flood event of 2022 occurring in eastern Kentucky, unfortunately left 37 people dead. Several locations received more rainfall on any other day on record for St. Louis, as a stalled frontal system combined with the tropical moisture and resulted in precipitation totals that rivaled daily records set by the remnants of the Galveston hurricane of 1915. I guess it traveled all the way up into the Midwest. Lambert International Airport in St. Louis reported 8.64 inches. St. Peters, Missouri, 12.34 inches of rain from this event. The Dardenne Creek in Missouri, the river gauge rose about 21 feet in just 7 hours, causing major flooding. This event resulted, excuse me, in at least one fatality, as well as extensive damage to homes and businesses. Flash flooding from the same stalled frontal system impacted portions of eastern Kentucky in the early morning hours of July 28th. Heavy rain, enhanced by the terrain, accumulated rapidly, trapping many residents in their homes. 4 to 8 inch totals were widespread across eastern Kentucky. You can see the amounts there in the lower right. And the Kentucky River crested at an all-time high at both Whitesburg and Jackson. Unfortunately, at least 37 fatalities occurred with this event, the deadliest flash flood event of 2022. And we won't stop with the heavy rain. Event number 7. After nearly 70 days without measurable rainfall in the Dallas area, the second longest dry stretch was broken in the second week of the month of August. A little over a week later, an early morning MCS, again, it was broken by light rainfall, but a little over a week later, an early morning MCS moved into the Metroplex and brought with it an incredible and record-breaking deluge with over 9 inches of rainfall in 24 hours, setting the record for the second greatest amount of rain in 24 hours for this area. While second all time, this was the wettest August day on record and also contributed to the wettest month of August in Dallas since records began in the late 1800s. The rapid rise of water from this deluge resulted in 174 high water rescues and 500 emergency related calls during the worst of the storm. Talk about going from one extreme to the other. This is certainly one of them. And you can see the hourly rainfall accumulation just bullseye right over right over the Dallas Metroplex, and some of the pictures of the impacts there on the bottom. Let's go to event number 8. We're now into the tropics. Hurricane Ian slammed southwest Florida. Excuse me. Ian rapidly strengthened on the morning of September 28th, with its maximum sustained winds rising to a high-end Category 4, speeds around 155 miles an hour. Later in the day, Ian made landfall at Cayo Costa Island with winds of 150. And then an hour and a half later on the Florida mainland, just south of Punta Gorda, with maximum sustained winds of 145 miles an hour. Ian then proceeded across central Florida before moving offshore into the Atlantic Ocean near Cape Canaveral as a strong tropical storm the following day. At the time, the storm was exhibiting some extratropical characteristics, such as a comma pattern you can see there kind of taking place on radar, and some frontal features in its outer circulation. Even so, Ian remained a hybrid tropical cyclone as it maintained a warm core. Later that day, while making a turn to the north-northeast, Ian intensified into a hurricane again as it moved over the warm Gulf Stream waters. The system turned northward on the morning of September 30th and accelerated. The damage across southwest Florida was extensive and will total in the tens of billions of dollars. 114 deaths occurred in Florida, and the incredible rainfall places Ian in third place for the daily 10-inch isohyet coverage, back looking at gridded data back to 2005. Flooding on the St. Johns River in northeast Florida lasted for months. You can see some of the before and after damage shots there from aerial reconnaissance or aerial photographs. All right, let's move on to number 9. This is Nicole, November 10th and 11th, a little late in the year for tropical activity. Nicole became only the 3rd November hurricane on record to make landfall in Florida, along with the 1935 Yankee hurricane and Hurricane Kate in 1985. Nicole crossed the same region in Florida devastated 6 weeks earlier by Hurricane Ian, and was the first hurricane to make landfall on Florida's east coast since Katrina in 2005. Despite being relatively weak, Nicole's large size produced widespread heavy rainfall and strong winds. Days of strong offshore winds flowing into the east coast of Florida produced severe beach erosion, especially in Volusia, St. Johns, and Flagler counties. At least 5 U.S. deaths and probably over $500 million in damage from Nicole. Excuse me. It was a weird hurricane season, and I started to do a little review here of the early season forecasts for activity as far as the Atlantic Basin. We look at the number of named storms, number of hurricanes, and the number of major hurricanes. The seasonal forecasts from many different experts were, on the whole, a bit on the high side. Interestingly, Colorado State University's forecast from late 2021 was one of the better forecasts, and I gave it a gold medal there. That was issued in early December, well ahead of the season. So what was interesting is that many of these forecasts kind of trended in the wrong direction, increasing the number of storms when in fact they probably should have stayed where they were instead of going higher. NOAA's May forecast and the update issued for August were not too far off, but those use ranges, which may actually be a good idea. In the end, if you'd simply used the long-term climatology of the seasons from 1991 to 2020, you would have nailed the number of storms that were named in 2022. And been only one shy of the number of hurricanes and one over the number of major hurricanes. Sometimes you just can't beat climatology. So you look here on the far right, the average season up here is about 14 named storms, 7 hurricanes, and 3 major hurricanes. And the season's activity was 14 named storms, 8 hurricanes, and 2 major hurricanes. So climatology for the win on that one. And CSU's early season forecast was pretty good too. All right, memory number 10. November 20th was the date of 2 historic snow events in Western New York, and that's when they came to an end. On November 20th, 2014, western parts of New York experienced quite a snowvember, which brought a crippling lake effect snow to Buffalo's south towns. The same day in 2022 was the date that most of the snow stopped falling around Buffalo, with nearly 7 feet accumulating south of the city. The meteorological setup, obviously very similar in both years, with snowfall totals also very similar. The main difference between the two events was that in 2022, the intense snowfall fell for a shorter period of time and over a slightly greater area. Between November 17th and 20th, the total of snow that fell in Erie County in western New York ranged from around a foot in Amherst to nearly 7 feet in Hamburg, a 60-inch difference of snowfall over about 20 miles. For the month of November 2022, just over 3 feet of snow fell at the airport in Buffalo, making it the second snowiest for the month on record. All of that snow fell between November 16th and 19th. Other lake effect snow records of note over a 10-day period, February 3rd through 12th, 2007, an incredible 141 inches of snow were measured in the town of Redfield, New York, about 50 miles northeast of Syracuse. In December 2001, Montague, New York, in the Tug Hill Plateau was buried under 127 inches of snow in just 6 days. And so those are some other records. And, the year did not end without a significant blizzard across parts of the Midwest and especially parts of Western New York. That is obviously an addendum that I did not get to. We could call it event number 11, just an incredibly intense and devastating blizzard for parts of New York coming just before the Christmas season, and also the Arctic outbreak associated with that cyclone that spread across much of the central and eastern part of the country. So we could call that memory number 11. It's just not included here today. So I'll give you the summary slide here. This was for Weather Brains. I did it back in December 19th. Happy to do it for CoCoRaHS today. And I think it leaves us a little bit of time for some questions if you'd like. So thanks for having me.
Yeah, Greg, thank you very much. It's very interesting, all the different events. Again, we didn't see a big wildfire season, it looks like, in 2022. And also we realized from a lot of CoCoRaHS reports, there wasn't a lot of hail, knock on wood on that, or reported in our area, but that was another piece that was kind of lacking in the year, during the year.
Well, remember the wildfires, especially in New Mexico, were early, right?
That's right. Yeah, you're right.
Yeah.
Yeah.
So there's a lot of activity there early, and then of course we got off to a quite an amazing start here with the atmospheric rivers in California. Also another event ending 2022 and continuing into 2023. We were quite busy with the California events and the flooding, the heavy snow, and some of the challenges out there earlier in January.
Well, I've got a couple questions that are coming in right now. Let's just kind of quickly, I'll throw those at you. And again, if we don't have time, we could follow up with some online. So the Iowa tornadoes back in March. So Doug wants to know what initiated such an early storm of that intensity. So what were the ingredients that caused this to be an anomaly?
Well, springtime is not an unusual, get into March, things can start picking up with respect to severe weather, usually a little bit further south, but it's not out of the question that you can get deep cyclones to basically form in the lee of the Rocky Mountains. And basically the ingredients needed for any tornado outbreak is essentially moisture, instability, and lift. And so the lift was supplied by that warm front that you saw on the surface depiction there on the slide. And it was really the instability and moisture streaming north across the Midwest that provided some of the fuel for those intense storms. Often, you also need the instability to be supported by heating of the day, and I think that's why you see an increase in the spring because you see longer daylight. So they didn't have that in this particular case, but they had everything else in place to produce the significant tornadoes that we saw.
And those were kind of right on the edge of, right, not too far behind the ones that went through Kentucky and so forth in December. So not too much of a lag for a busy winter season back there with severe weather. Here's Jackie lives in central New Mexico. She said that in 2022, rainfall came at atypical months, June and October. But the typical monsoon months of July and August were pretty dry. She was wondering if this is a type of pattern, is an anomaly, or is this something she may see in the future, a shift?
So I'm not exactly sure where she is, but much of the Southwest saw well above normal precipitation in that typical monsoon season. So maybe you were shadowed, or you're in an area that things didn't quite work out. And again, that's the nature of monsoon thunderstorms, is they can be very hit or miss. In other words, you can have a storm that be 10 miles away, and it can remain dry where you are. Some of the higher anomalies that we saw with precipitation across New Mexico were over the extreme west southwest part of the state, so not necessarily as far east as central New Mexico, but really the Arizona New Mexico border up into Utah, even farther west. Death Valley, California, had a record rainfall event that caused widespread damage across Death Valley National Park there. So you just didn't pick it up where you were. Which is unfortunate. But there were many areas that saw quite an active monsoon season and a long monsoon season in 2022.
Yeah, I made the mistake in September of driving from Vegas into Death Valley National Park, and
Yeah.
I took that long, long road, and then all of a sudden got there and the road was closed and it had
Yeah.
washed. So it's
You'd
like,
think
oh
they'd
well,
tell you
okay.
that before you started.
Well, I think the signs were gone or something by that point, but yeah,
Interesting.
it,
Yeah.
it was interesting indeed. Terrence was wondering, you mentioned wedge tornado. Could you just quickly describe what that is? He didn't know what a wedge tornado was.
Well, if you saw the picture on the slide back there, it's a description of what the tornado looks like from a distance. It essentially looks like this wedge, right? It has a little narrow at the bottom and a little broader at the cloud base, sort of like a wedge shape to it. Also, sometimes when you don't see that wedge shape, but you see, the images or videos of these large destructive tornadoes, they're also called stovepipes because they're based straight up and down and dark gray, looking very much like a stovepipe. So it's just a description of the character of the tornado.
Sean writes in, and he was wondering that what are your thoughts about how much climate cycles such as ENSO influenced these weather events, the intensity of them, and the geographic placements of the events? And he didn't refer to any specific one, but what was ENSO's effect this year?
Yeah,
Over
that's a great question. We're kind of coming out of, I believe, the third year of an ENSO cold phase ENSO, or La Nina as it's known. La Nina's influence on the general weather pattern, especially in the warm season, and you probably noticed most of my events, most of them, a third of them were warm season events. There's not a strong connection between the ENSO phase and the circulation over the United States during the warm season. There is some connection and some correlation to weather, especially during the cool season and perhaps early in the spring. Springtime events for severe weather, there is some correlation when El Nino or La Nina is relatively strong. That can result in an active severe weather pattern across the South. We did see a number of severe weather events across the South during the early part of 2022, perhaps connected somewhat with the ENSO phase. But there are all these other factors, right? There's climate change in general, and there's day-to-day variability in weather. So all of these things interact in ways that can make it incredibly difficult to pin weather events on one particular climate cycle or climate phase. It does appear the long-term forecasts are beginning to indicate a transition from the cold phase of ENSO to the warm, meaning El Nino will return perhaps late this year. If that happens, there's the prospect for wintertime tornadoes in Florida. Depending on the strength of El Nino, there is a connection to tornado activity in Florida and El Nino. El Nino also is a pretty dramatic warming over a large area of the tropical Pacific Ocean, and that'll contribute to warmer temperatures, most likely in other parts of the world, and a change in the jet stream pattern that can become quite active and quite destructive potentially, depending on the weather regimes that set up across the Pacific and affect parts of the western United States. So it's usually the strongest signal is usually in the cool season months, and there's lesser connection to ENSO phase in the summer months.
Greg, correct me if I'm wrong, this is the third year of La Nina, right? We've been in.
Yeah, it's
So
pretty unusual.
pretty
Right.
unusual, right? Yeah.
Yep. Yep.
Yeah, I'm thinking that. Okay, we got a couple more questions coming in here. Edwin was wondering, and you're don't have a crystal ball, but he maybe related to this. What you just mentioned was that what are the chances for another hot wash hopscotch across the US in 2023?
I'm glad you like the alliteration there, but I did too, and I found that rather interesting from the perspective that in those areas where it was very hot, you obviously weren't seeing much in the way of precipitation. Um, and that what really surprised me was the proximity to those heat warnings that were in effect and the flood warnings. Only a few counties separated the two. And normally when you think of heat, you don't think of, heavy rain or flooding rain, because that would usually cause the clouds, and precipitation would usually keep the temperatures suppressed. So they're very rarely coincident with one another. But what really stood out to me was the proximity between these two extremes. And from a meteorology perspective, it's not really too difficult to understand. What happens is you set up an environment, usually in the summer months, where a large ridge of high pressure will become established over the central United States. It's usually too warm for thunderstorms. In other words, the lack of buoyancy, because the entire atmosphere is warm, it's very difficult to get thunderstorm development. But what you do have in those environments is a tremendous amount of moisture that's basically what we call capped, but that moisture has to be released. That moisture instability that builds under the heat dome has to be released somewhere, and it's usually on the edge of the hotter air. And so that's what that hopscotch was really, especially in the central United States, that's what you were seeing there. You were seeing the hot, very unstable air mass suppressed in the ridge over the middle of the country, but the energy from that heat and moisture released on the edge in the form of really intense thunderstorms and repeat thunderstorm activity that tends to develop along the edge of what we call the cap or the heat dome. And so this is something that it was quite apparent in late July, and could very well be a function of climate change, in that you are generating tremendous amounts of heat and instability that has to be released somewhere, and unfortunately, it's released in the form of flash flooding and extreme rainfall.
Yeah, thanks for answering that. Oh, my back. Yeah, I'm on still. Thanks for answering that one. Here's Kathy lives in Northwest Wyoming, and she said you didn't mention this one, but in her mind, the Yellowstone floods that happened, and if you could speak a little bit about that, maybe summarize, and if you remember these,
Yeah.
explain what contributed to the severity of that flooding.
Yeah, thanks, Kathy. And I'm always I always tell folks, send me your send me your events throughout the year. You may end up in the meteorological memories, and that is a memory. I do remember that event. Extreme high end precipitation occurring along, I believe, with snowmelt. Resulted in the devastating floods we saw, I think, along the Yellowstone River and parts of Yellowstone National Park. It does appear as if this area of the country is beginning to receive more precipitation than normal, especially in recent years. It seems like there are a lot of high-end precipitation anomalies across this part of the country. When you combine that with the snow melt and the potential for the terrain that exists in those areas, that's a recipe for disaster, which is what we saw up there. It was, I will say, I won't shy away from the fact that it was definitely a challenging forecast. It was very difficult ahead of time to foresee. And I think part of that is this relationship that we have. We knew the rainfall was heavy, but the warm up and the potential snowmelt that was also occurring is a little difficult sometimes to assess in terms of the real-time forecasting. So that was a challenging event for forecasters, and one that I do remember.
Thanks, Greg. Here's Gerald lives in Eastern Kentucky, and he was wondering about the Eastern Kentucky flooding event. Do you have a sense of the frequency and rarity of that sort of a setup for something like that to happen there?
So what is interesting in the bigger picture with respect to the extreme rainfall events of this past year, overall precipitation amounts across much of the country were below normal. But we had these extreme events: St. Louis, Kentucky, Dallas, Jackson, Mississippi, Death Valley, Yellowstone, had these isolated kind of local events where the devastation was quite remarkable, and the rainfall amounts were also striking. And it just goes to the difficulty of attempting to forecast some of these things that occur over relatively small scales. Kentucky is no stranger to significant flooding events, and a lot of that has to do with the terrain. So we all know how the terrain can basically focus the rapid runoff that comes from extreme rainfall and cause the devastation like we saw there in eastern Kentucky. We saw another event occur not very far away in extreme southwest Virginia, also a very narrow valley that got very localized, just a few miles across, ends up with 5, 6, 7 inches of rain overnight. All of that comes down one basin and creates devastating results. So these things again are not uncommon, especially in the presence of terrain, especially when the ground is already saturated, and also not uncommon during the warmer time of the year when you can set up these thunderstorms that produce the amount of rain that you saw in those cases. So return frequency for that particular event, I don't have the annual recurrence interval in front of me, but my guess is it's probably greater or less than a 1% probability of occurring in any year, based on what we know about rainfall extremes.
Thank you. And here's one from Rick in New Hampshire. And so a neighbor of yours, one state away from Vermont, he was wondering that the recent events in New England are similar to weather that they had there in the 1930s, the most extreme decade. Do you have any metrics for comparing mild and extreme weather periods? And that's his question.
So New Hampshire is one of my favorite states. As you mentioned, Henry, I'm from Vermont, but my mom actually lives in northern New Hampshire. I'm not familiar with the extreme events in the 1930s. I'm not sure if you're talking flooding or winter weather, but New Hampshire is one of those states that definitely has its fair share of extremes, and it certainly has the elevation. In the short term, I think I just saw a forecast of the forecast wind chill temperature potential of 91 degrees below zero at the top of Mount Washington on Saturday. So buckle down and bundle up up there in northern New England, because you're in for quite an extreme onset of wind chill temperatures for the first part of the weekend. It's going to warm up quickly after that, but no, I don't have the record books in front of me to know how the past year compares with the 30s.
It's funny. When I was a kid, we lived in Freiburg, Maine, which is right near North Conway, New Hampshire.
Yeah.
And we hit 34 below January of 75. I remember I just gotten a new Maxman thermometer. Got in the car, we were heading somewhere, and sat on the vinyl seats, and they crunched like potato chips. The vinyl
Yep.
just so that cold weather can really,
Yep.
maybe things have changed nowadays with cars, but that's a memory I'll never forget.
Good
Henry,
winter
that's better
memory.
than
Yeah.
that's better than crunching the thermometer, which that's a story of the
Oh
record
yeah,
coldest in Colorado. They extracted the thermometer and we're going to take it to the lab to test, and someone sat on it. So
Oh.
yeah, yep. That was not fun. Not fun with that there. Let me get one more question. I know we have others, but maybe we can look at those offline. And again, back to the Northeast here. Adrian is talking, Dutchess County, she lives, she says, experienced severe drought. Her record's 30 inches, over 30 inches below the previous year. So that's quite a bunch for this year. Areas 2 miles to the northwest and 3 miles southeast receive rain frequently, but they didn't. She wasn't sure why this happens. We get more frozen precipitation in narrow swaths as well. Any thoughts on this? Suggestions on why? And again, I probably know the answer too, but maybe you could elaborate just quickly.
Sure. Yeah, so I love Dutchess County too. It's beautiful up there. I lived in Dutchess County for a while. My first job in meteorology there in Southeast New York. Yeah, there are a number of locations in the Northeast that are well below normal precipitation wise, but it's kind of a patchwork. Like I say, you just have to go a few miles away, and they don't seem to be suffering the drought quite so much. And this is probably related to most of the precipitation coming through thunderstorms, which are usually quite localized events. It's been an interesting winter along the I-95 corridor, where much of the I-95 corridor is not in drought, but they're in a snow drought, and so the definition of a snow drought could be actually the lack of any precipitation. But in this particular case, it's the lack of precipitation falling in the form of snow. They've had plenty of rain. I think most of those areas are at or even a little bit above normal, but they've just not seen a lot of snow this winter. And that could be a problem for Dutchess County too, where you are in perhaps drought where you are, and without any snow cover to contribute to some soil moisture, that problem could continue. So yeah, it's a patchwork, and I think it also points to the challenges of doing day-to-day weather forecasts. The variability over relatively small scales makes a forecast extremely difficult to be accurate.
Well, thank you. Well, we want to thank you for taking your time. Do you have just a second to kind of tell the folks what you do there at the
Sure.
Weather Prediction Center? Maybe just a quick summary, so they may not be
Sure.
familiar with you. And
Yeah.
yeah.
Yeah, so I'm chief of forecast operations. After nearly 30 years in meteorology, I often say the reason I'm a manager is because my forecasts weren't very good. but but I love forecasting. I love meteorology. I consider myself an equal opportunity meteorologist. I'm fascinated by everything from winter storms to tornadoes to tropical weather. And the Weather Prediction Center focuses on precipitation, and especially precipitation extremes, but also temperature extremes and winter weather. There's staff of over 30 meteorologists. I'm supervising 24/7, 365 days operation. We're one of the national centers for environmental prediction here, and we provide support services and detailed forecasts for the contiguous U.S., Alaska, Hawaii, and we also support the National Hurricane Center. We are the backup for the National Hurricane Center if they need that. And we also take over tropical products and specialize in tropical cyclone rainfall. So there's a lot that goes on here. It's a perfect job for someone who loves weather, and the staff that we have here is great, and they love weather too. And it's something that changes every day. So that's what I do.
Yeah, well, you do a great job, and thank you for doing what you do, and glad to see that CoCoRaHS can help you folks in a lot of your endeavors there, and that our folks out there, our viewers may not realize how important some of your observations do play in helping Greg and his team there with their jobs.
Yeah,
So
absolutely, Henry. Let me back you up there.
sure.
CoCoRaHS is crucial. The observations you take are critical to our understanding and assessment of weather events. I'm a CoCoRaHS observer, and I've got the rain gauge. Although it broke, I think the inner tube broke from being. I should have taken it out before it got cold just around Christmas time, but it still holds enough water. I can measure the rainfall every day. But I refer to the maps all the time. I know our forecast staff do as well, to try to understand, what just happened over the last 24 hours. And we often have to do storm summaries, and it really helps to have those observations from across the country and around the world. So thank you.
Well, there you have it, folks. Right from the people that use it, that your information is used, and it does play a critical part. So don't hesitate in taking those observations, and they do matter. And so we thank you for your observations out there. Well, Greg, thanks for taking the time. I know you have a busy day, and appreciate this annually that you've it's one of our highlights to look back on what happened, and hopefully it'll be a benign 2023. We won't have too many next year to look at, but you never do know. So,
Thanks,
folks,
Henry. Yep. I just saw Ken Dewey's question on there, and Ken,
Oh.
to answer you, I think the folks are recording it, so you'll be able to pick it up later.
Yeah, well, this will
Use-
be out there again. And again, folks, if we didn't get to your question today, we'll have if Greg can do that, follow up with a couple of answers on the ones that we didn't hit today. So
Glad to do it. Thanks a lot.
yeah, great. Thank you. Appreciate it. Well, folks, keep an eye out for the announcement for our next Weather Talk webinar. We have one in the works. We're getting them together for 2023, and we'll be advertising those soon. So until next time, this is Henry Regis for the rest of our CoCoRaHS team saying goodbye for now and have a great afternoon.